Okay, so me, that's a good sign to start with. Okay, actually, what I'll do is I'll give these back to you, so you can have a look, so you can check your own over. I have to enter the marks in, but I'll give them to you. So Deacon, Jax, there's your two, and then you guys don't put any marks on this. I'm going to mark it. Okay, so I'll go through it. Okay. Okay, so first question, you just had to use your calculator for. 3375 is a perfect cube, right? The second one, this one just tested your order of operations. Okay, so I had 8 plus 8 to the 4th, subtract 4 to the 4, 4 squared, minus 4 to the 4 over 2. So what I did is I just did this. Okay, just in my own work, I did that to begin with. All right, so just working from left to right, this is now 16 to the 4th. Agreed? Yeah? Okay, and again, you were able to use your calculator for this. There probably is a different way in which we could have done it, but I would just use your calculator here. So now I have 4 squared subtract 4 to the 4th. Well, that's 16 minus, what's 4 to the 4th?
256.
That's right, good for you. 256. Okay, so now I have 16 to the 4th minus, what is that? 16 subtract 256 would be what? Negative 240?
Yeah.
And then I divide that by 2, so that's negative 120, right?
Yeah.
Now take 16 to the 4th and add it to 120.
65,656.
There you go. There's your answer. Okay. All right, so far? All right, just going to back out of this. Okay. Square root of 100 is what? 10. Which power is equivalent to 264? So when I have the cube root and I want to make it an exponent, what do?
Put it under 1.
Put it under 1, that's right. So 264 to the
1/3.
1/3. That's right. Okay. 3x to the 1/2. Well, if the cube root ended up being 1/3, what does the 1/2 end up being? Square root. So there's your answer. Square root of 3x. Okay. So far, so good? All right. This one, without a calculator, we're going to solve it. So I've got this like that. So far? Okay. Now, what do I do with that exponent first? Because I want to get rid of the brackets.
What I did is I multiplied 4 by 9 and 4 by 2. Is that right?
Okay. Yes and no. I think you said it incorrectly, but I know what you meant.
Like
This is yeah. So like as if that's an exponent of 1 there, right? Yeah. That's exactly right. Yeah. So 2 to the 4 over 9 to the 4. Is that what you got there?
Yeah.
Okay. And now because I have 9 divided by 9 to the 4th, what happens now? What do I do with my exponents?
Subtracting.
I subtract them. So I would go 1 subtract 4. Now, this looks kind of goofy the way I've got it written, but what if I did this? What if I go 9 times 9 times 9 times 9?
Then
Right?
I cancel one of the 9s out.
Then I cancel one of the 9s out. What am I left with? 2 to the 4th, which is 16 over
9 cubed.
9 cubed. So 9 times 9 is what? 81. 81 times 9.
729.
That's right, Jax. Okay. We all right? Question 1A, is it a perfect cube or a perfect square?
It's a perfect square.
Perfect square.
Square root the number. You got a perfect number is 32.
That's right. Excellent work. And then what about the next one?
Perfect cube.
Perfect cube. What's the cube root of 10,648?
22.
22. That's right. Okay. And then in the next one, we had to do 17 cubed, which is 4,913 yards cubed, right? And in B, I have 11 cubed, which is 1331 feet square. Done. Oh, that's cubed. Cubed. Okay. All right, I like this guy here. This incorporated a lot of work here. So there are multiple ways in which we could do this. So the first thing I'm going to do is just write it out. A squared, B, C to the 4, A, B cubed, C squared. And all of that is squared. And over B squared, C to the 5, all cubed. Okay? So depending on what you like to do here, I would have narrowed down everything on the top in the brackets first. Okay, so this is all multiplication right here, right? So if I've got A squared here and A here, what do I do with those exponents? If I'm multiplying, what do I do with the exponents? I add them. So what's A squared times A? A to the 3rd, right? B times B cubed?
B to the 4th.
C to the 4th times C squared?
C to the 6th.
C to the 6th, and all that is squared. And on the bottom, I have the cube on the outside, so what do? What do I do with that 3? Multiply it by the exponents. Yeah, that's right. So B squared becomes what?
B to the 6th.
B to the 6th, and C to the
15.
15, okay? So I have one more simplification to do on the top before I do the top and bottom. Now I'm gonna pop that squared through, so what do I have on top here now? A to the 6, B to the 8, C to the 12, very good. And all of that is over B to the 6, C to the 15, right? Okay? So I draw my line like this. A to the 6, can I cancel it with anything? No, it stays as A to the 6. B to the 8 over B to the 6 is what?
B to the 2.
B to the 2, B squared, that's right. And it goes on top, correct?
Yep.
Because if I have 8 up here and I cancel it with 6 down here, I'm left with 2 on top, right? Now using that same idea, if I have 12 C's up here and 15 on the bottom, when I cancel them out, what am I left with?
C cubed.
C cubed on the top?
No.
On the bottom, right. There's your answer. Simplified version of it. Okay. You guys all right there? Okay. All right, need to change root 45. Root 45 into a mixed radical. So what am I looking for here? How do I change it to a mixed radical? Right, I'm going to find a perfect square that goes into 45. What is it? 9. So I go square root 9 times square root 5. And what is the square root of 9?
3.
3. So I write it as 3 square root 5. All right. Okay, and then the next one is cube root of 40. Now what am I looking for? Okay, can I take the cube root of 40 and get a number? A whole number? Let's put it this way. Is 40 a perfect cube?
No.
No. Is there a number that divides into 40 that is a perfect cube? Which one?
8.
8. So I'm going to go cube root 8. And what do I times 8 by to get to 40? 5. And what is the cube root of 8?
2.
2. So I have 2 cube root 5. Good? The last one, 243. This one was a little trickier because it was bigger. You could have done this a couple ways, but we actually just, what is a perfect cube, or sorry, a perfect square that goes into 243? What's the largest one that goes in? Try a couple in your head and see how this goes. Use your calculator. This is the one time I would suggest using your calculator. Go ahead.
9.
9 works? Yeah, keep going though. 9 definitely works. Let me do this. Actually, what's 243 divided by 9?
27.
27.
Yep.
Okay, let's do it this way then. So I have square root 9 times the square root of 27. Okay, what is the square root of 9? 3. Square root of 27. I want you to look at the number 27. Is it a perfect square? No? Is there a perfect square that goes into 27? Nine. 9 times what gives you 27? 9 times what? What do I times by 9 to get 27? What is it? 9 times 3, right? So I have this, 3, square root 9, square root 3, right? What is the square root of 9? So I have 3 times 3, square root 3. And what's 3 times 3? 9. Okay. Quick question for you. As I look at this number right here, if I were wanting to put that back into a perfect square, or sorry, into a singular radical, what would I have to do to the 9 to change it back to the other way?
Put it under 1.
No, that's to change the exponent from a negative to a positive. Okay, I can't multiply these because it's not a square root times a square root. Can I make 9 a square root? And if I can, how do I do it so that it's under a square root and it still becomes 9? Say again?
Square root of each one.
Yeah, more or less. Okay, now the reason I'm getting at this is I'm going to show you why in a second, but here's what we would have to do. Square root 9 squared. What is the square root of 9 squared? What is it?
81.
No, the square root of 81 is what?
9.
9. The square root of 9 squared, what is it? It's 9. So by square rooting it and squaring it, it's still 9, right?
Yeah.
What is 9 squared?
81.
81. Watch this. Square root of 81 times the square root of 3 is 243. What is the square root of 81? 9. So I could go through this to get to there, or I could have done a larger perfect square in the first place and got it to work. Yes.
In my call,
My assignment, I just leave the square root of 9
Yeah.
times square root of
3?
so it's 27, right?
No.
Oh.
No. This is only part way. To get a full answer, you have to get it right to there. Okay? All right? Okay. 2 more questions. This one was interesting because it said express as a radical with positive exponents. How do I make that a positive?
Just
How do I make it a positive?
just put it under 1.
Yeah, that's right. So I put it under 1 like this. And it becomes a positive. So far, so good? Jax? Don't remember that, Jax? Okay. Now, I need to change it to a radical. Which part of that fraction is the radical portion of the fraction? The bottom half. So what do I rewrite this as? There's the answer. Okay. 2 quick steps. First is change it to a positive by putting it under 1, and then changing it to a rooted value. All right? Jax, follow that?
yes, I do.
Okay. Okay. These 2 questions, again, were probably calculator-related questions. But I'm going to work with it without the calculator right now. Okay? What do I do with the exponents? Times them. And then, because it's a fraction, each one gets that value, right? So I'm going to shortcut here. That's going to give me 2 to the negative 6 over 3 to the negative 6. And how do I make those things positive? I can put it under 1, or what else can I do?
Swap it.
That's right. It's exactly correct. You can swap them. 3 to the 6th, 2 to the 6th. Just like that. Now you can use your calculator and you can solve for it. And it asks for 4 decimal places. So that's what I believe what it works out to. 11.3906.
Yep.
Okay. All right. And the last one. 1/4 negative 3 divided by 1/4 plus 2, and then all of that is to negative 2, right? Okay. I have a divide here, so what do I do with my exponents? Subtract them. So I'm going to take negative 3 subtract 2. That's going to give me negative 5. And all of that is to the negative 2 equals. Okay, so negative 3 subtract 2 is negative 5. That's all to the negative 2. What do I do with these 2 exponents? Times them. And what do I get when I times them? Yeah. Okay, so, excuse me. So I have 1 over 4 to the 10th. And this one is different because on your calculator it works out to
0.00000953.
yeah, that's right. And most calculators will give you this.
decimal place.
Just move the decimal places, yeah. Okay? But when we get back from this break, I will go through that with you and explain, because we're gonna use this a bit more often,
Okay.
scientific notation, but you should have been taught it already, I don't know why you haven't. All right? Okay. So what's gonna happen then is today, you can work on your review for chapter 4. And basically you could do that, I would say, I would do that today. And I am going to go through the start of chapter 5 with you tomorrow and factoring. I'm gonna go through it. So I will live broadcast tomorrow and Friday. If you're in here, that's great. But I will go through 5.1 and 5.2 with you on the live broadcast. I'm gonna put that in Moto as soon as I'm done here. Okay, so you have the rest of today to just work on it. If you have questions about it, you can, but the assignment itself is the only thing that you're going to be assessed on in this class. Okay, so I will have those up on Edmodo right away. So I'll take those back. Or not Edmodo, but Power School. Yeah. Okay, so you can work through your stuff now. I'll put these assignments on Power School, and then I will, I'll put on Edmodo what our plan is for the next few days. Okay? And we're done.